Hello, we're team 2016-94. This is Xudong and Xiaofei. We'll be presenting about our sentiment analysis-based real estate trend prediction module. Since the subprime mortgage crisis in 2008, the global real estate market has suffered much and become much more volatile and unpredictable, which makes the accurate prediction of real estate market trend ever more desired. Consequently, there have been many attempts to predicting real estate market trend. Despite the variation in traditional real estate forecasting models, they share one point in that they use only numerical data. However, empirical knowledge on the field of real estate market tells us that there indeed is a direct correlation between public sentiment and confidence level and market trend. Therefore, for our project, we will test a novel approach to real estate trend prediction based on sentiment analysis of real estate related website articles. Methodology-wise, the entire module can be narrowed down to four essential steps: data acquisition, data processing, sentiment score generation, and prediction module. We will go over each step in more depth to present a clearer view of our module. The first step is data acquisition. First of all, we need to find opinionated data recorded in digital forms and in large quantity, where better to look than the internet. For this project, we choose Bloomberg, Wall Street Journal, and New York Times as our main data source, since first, they are reliable, convincing websites, second, they are influential among a very large user volume, and therefore can also to some extent reflect the sentiment of their readers. Third, they provide easy-to-use Python-compatible API. Article crawling is achieved through a Python-based software called the Beautiful Soup. For real estate market indicator, the house price index HPI, published by the Federal Housing Finance Agency, is used. The data that we recorded is between 2007 and 2016. Xiaofei will now present a brief demo for the product that we used.
So we can see from this program, we utilize the online news API to acquire the URL address of the news articles starting from 2007 to 2016 from the online news source such as Bloomberg, Wall Street Journal, and the New York Times. And then store them in the CSV files. And then we use another news scraper Python program to utilize the Beautiful Soup to scrape the whole articles contained in the URL address that we acquire in the formal process, and then store them as TXT files. To save our time, we will not execute. We will not execute the Python program for you.
Now that we have all the web articles, we need to process them before we can use them. We'll need to clean them, so to speak. Therefore, the data is stamped, tokenized, and have all their stop words removed. And now that the data is ready, our next step is to generate the dictionary of the top 138 sentiment words. Here we made a very broad assumption that the top 138 sentiment words from our 9 years worth of data is the most typical sentiment words anytime for any real estate related data. Based on that, it will be adequate enough to represent the overall sentiment of any real estate related topics. Even if we only analyze those 138 words. This assumption is based on Zipf's law and recent study on the field of opinion mining. More detail will be given in our paper. Anyway, in order to find the top 138 sentiment words, we need to perform a word count on our dataset and filter out every non-sentiment words. For example, here is the result that we have. Is top 10 of the positive and negative words that we find. Now Xiaofei will demonstrate the code to do that.
So this is the core program of our project create. First, we use the NLP toolkit to tokenize and remove the stop words as well as stamp the words in all the TXT files. Then we use the Spark. To map reduce of each TXT files to perform word count as well as filter out all the non-sentiment words. then we store all the sentiment words and their respective volume in the CSV files. So we will execute this program, and then it will use the Spark to perform the word count and the filter of the sentiment words. In this process, because we have a large quantity of articles, so we utilize the MapReduce for 3 times to parallelize the calculating process that we can see in our code. So we utilize the MapReduce for 3 times because if we do not use them, it will perform a long time. And now we can see the result of our program, and it has saved in these word count files, and then we can see from these files and all the top ranking words, the sentiment words that we acquire from the Spark program.
Now that we have the most popular sentiment words, we can use it as a reference to retrieve sentiment features from the articles. In order to process the sentiment feature into quantitative data, we decided to manually assign sentiment score to each word in our dictionary. The sentiment score of each word is between -2 to 2, depending on the polarity of that word. The overall sentiment score of a month is calculated as the sum of each word's sentiment score times the relative frequency of that word. Here we can see an example. For example, let's say that in this month we only have 5 words, and you can see they all have their sentiment score attached, and they all have their volume here. And to calculate the monthly sentiment work, you basically just use the sentiment score and multiply that by the relative frequency of the word. And so it's this one, and you plot them together, and you got the final monthly sentiment score. The popularity is derived from 2 sources. One is web articles that we extracted, and the other is the search engine query data. For web articles, we would count how many times each word in dictionary has appeared each month, then use the equation that we'll give later to calculate the monthly sentiment score. We also incorporated search engine query data in our design, since we believe that although news sentiment can reflect part of human behavior, it alone is not enough to make the prediction accurate. The content of a news article, for example, with very few viewers, cannot indicate the actual fluctuation in the real estate market, however strong the sentiment is. Search engine query data, on the other hand, can better reflect the overall sentiment of the public. For each word in the dictionary, we would import its monthly search volume from Google Keyword Planner. For instance, for keyword collapse, we would look for the search volume of real estate plus collapse, or maybe housing plus collapse. The relative interest in each word would then determine how much it contributed to the monthly sentiment score. The detailed equation for both approaches are here. Okay. Now Xiaofei will demonstrate the code.
So in this program, we read in the TXT files that contains the top 138 sentiment words, and then we also read in another TXT files that contain the corresponding sentiment score of each word, and then calculate the monthly sentiment scores according to the formula we present in the website. For example, here we can calculate out the sentiment score for the first month in 2007 in this program. the results is the result we can see has been calculated by this program.
And so we record every time after we get a monthly sentiment score, and the result is on the left. We have this graph that shows the monthly sentiment score all the way from 2007 to 2016. And on the right, this light spiky one is the one that we incorporate search engine query data. Okay. So now it's a part for the prediction module. In order to determine the future trend of real estate market trend, we need to feed the HPI time series and also the sentiment score time series that we just got into the machine learning algorithm. Here we employ two different regression modules. One is support vector machine and the other is Arrowmax module. To save time, I will not go into detail about how this module work, but here is the result that we have after running all this test. As you can see, in general, Arrowmax outperforms SVR, and Google search data outperforms the web article. And we also took a shot at predicting the 2017 real estate market trend, and here is a result from all four of our approaches.
So I will demonstrate the code execution. In this program, we use the pandas statistic analysis library to perform the Arrowmax prediction. We can see the so we will perform this prediction module. So we can see the model we generated using sentiment score 1 that is generated from web article, and then the corresponding prediction for September 2016 to June 2017. And the central line represents the most likely outcome for HPI statistics, and surrounding it is the probability of its outcome in a Gaussianly distributed manner.
So now for conclusion. And based on the result of experiment, we can see that Arrowmax module is clearly superior to SVR module in predicting time series that does demonstrate a seasonal pattern. And also search engine query data, it can improve the prediction accuracy a lot. And for our experiment, I would say we did create sentiment indicators that does correlate with HPI, and it does have the potential to predict real estate market trend. However, at the current stage, for real-world application is still not ready. It still need many improvement. We will discuss this in more detail in our report. So thank you so much.